All right, so on the second half of the class, we are going to discuss mostly about projects. So from next class, you all should bring your questions related to your own project so that we can discuss here and everybody else can learn. So for today, I feel free to stop me anytime you need to have discussion on your projects or put on the chat window so that I can answer them. Otherwise, I'm just going to share this previous project report by other students. And this was a project report in 2018. That's the first year I start teaching this class. And because there were 7 students, each student have their own project. Has each had their own project. So that's Peggy, and she was a master student, so a PhD student. So she was a grad student that time. So our project was mostly remediations of a contaminated site in Los Angeles. And that contaminated site is brownfield site. It's a definition of a brownfield means a definitions. It's a type of site which is called brownfield because it's industrial or some site which is abandoned and it has enough pollutant that you can't use anything else until you develop it. But it's not so polluted that you have to call it superfund or extremely polluted site for remediation action to be taken place. So most of the brownfield site can be redeveloped if you use some kind of phyto or bioremediation techniques to remove or manage those pollutants. And because those brownfield sites have low nutrients and doesn't grow anything, it has pollutant, you have to apply some nutrients for the plant or biological organism to strive. So that's why she was exploring the use of biosolid, which is a solid materials that comes out of wastewater treatment plant. It has extremely high concentration of nutrients and also compost to develop these techniques. Um, so she has very specific locations. She told about different types of techniques, how much it cost, and she showed that the compost based techniques cost can be 3.6 million. So again, these are, as you see, these are based on different location or site projects. She's not coming up with that number. Then she come up with this cleanup plan. She either copied from where somewhere or she made it on her own. The point I want to say is when you write every try to have at least a picture in each of your page. Don't keep write like entire page without a picture. Just it's not it has to have a right balance between pictures and text. So see, this is basically conceptual design. So she's right about all that, what assumption, what kind of plans to use, where to get it, all that. She basically wrote all that stuff by herself. And again, this was the first time, so I was really not, no, I was very open to whatever they want to do. So let me see if I can open this one. So this was done by 2 students, Jerry and Merrick, that year. They were use of biosolid for land application because biosolid is a waste. So they are looking for different techniques or ways to alternative use of biosolid so that it doesn't go to landfill. So they have again the same process. They write stops. So this is just 1 or 2% project. So that's why it's not very details and all that. But when you're writing your own projects with the 7 students, I am more expecting more. So let me go to the um, 2019. Um, the outline. So, oh, this is the example I gave this year because it was there before. Let's say team flash final draft. How that look like. So let's say this is the rough draft look like. So when you send me a draft, you can have comments on all that, but make sure you have a title page which has title and the members names, group people, all the students names and all that. And here they list what different members did. So that way it's kind of clear that everybody worked. So you should put somewhere, at least an appendix or somewhere, a role of different team members. And so this is basically the project was cultivating a garden with leftover food. Means this, they talk about how you can take the leftover food and create compost, so that you can use those as a fertilizers for the garden in your system. So this is more about a concept of, imagine all the schools where they have a lunch programs, and they use these organic, let's say they peel all these carrot, all that stuffs that they get, not about the rotten food or the processed food, but talk about the plant-based food, raw food, and then they can use those to quickly make compost, because it doesn't have much chemicals. And if you make those compost, you can use those compost right in the school to create garden. So that's the whole idea of this project. So they have abstract introductions, then they write the case study where they are going to do it. They write about methods or discussions, and they talk about all that. So I'm going to show the my uh, all markup. So whatever they send, I start editing, or I start putting some comments. That way you can see all these edits, and then basically I start suggesting what they should do, all that stuff. So you see there is a flow chart. So you can create this kind of flow chart on your own, as opposed to explaining everything on a text. You can do that by having a tables or flow charts or a graph that help you explain your presentation better. And then they have all these techniques. Again, you will not know what does that mean until you read the paper, but at least you can take these pictures and put on your presentation file, or presentation, or PowerPoint presentations, or Google Slides, and for your final class. So this is just basically table analysis. They did all that. So they come up with a different form of things you can buy. What's the advantage, disadvantage for these compost making systems? They have references, all that. So this is their project. Okay. Um, so this is the draft form, and let's pick up another one last 2020. Um, let's see. Okay, this is a project somebody did. An anaerobic digester could turn a less organic waste into energy solutions. I know that one group is working on or the food waste to energy. So that's kind of similar, but that they are specific about a specific type of food waste. But this is also, you can see their projects. They write about what's the process in anaerobic digester, things break down, they write the equations, they explain how it works, all that, what's the output. They talk about result discussion, but as you see, this was one of those draft which didn't have any much figure. So it was really not easy to read. You got to have tables and figure to make it easy. And then ultimately in the draft also you got to share all the references. Hold on. Okay, so let me see if I see a slide. Usually they some share the slide, but most of the time it's Google slide, so I don't really save it. If online, I could look for maybe 2019. Project. No, there is no slides because they have it in um, on the Google slides. Okay, so these are the few things. First thing is make sure that you are telling a story. Have a balance of text and figures, and tables or illustrations, or even if you have data you can present. I know that William did lots of calculations, and so something that not always possible for every type of project. So their project has multiple graphs that they come up with their own calculations with the equations. So again, in the draft stage, I will see those, and I will, if I see a potential where you can do calculation, I'll suggest that. When I suggest that, that means that's all you have to address and send it to me in the final stage. So in the final, when I look at how I evaluate you, I also see whether how you respond to comments. So that's why because that's the whole process of project writing. It's not about how good draft you write. It's also about how you address the comments and response to the client. So that's the whole process you'll also learn in the feedback process. So I would say that don't waste too much time now. Just work on whatever comes to your mind. Just write, and then read, and then whatever. Because don't worry about the page limit for now. Um, just when you are submitting to me, then decide which one you can move it to appendix. Because you can always move some stuff to appendix if you write too much. And work with a team and work on that aspect. Um, Okay, so that's all for the examples. And again, we'll next class we'll use each person's. I know that one team already sent me draft, so I'm going to edit that and send it to them, respond them hopefully tonight or tomorrow. That way they have their comments, and then I could, if their team is okay with that, now that I can share that, or at least in the screen, so that you can see how I look for steps. Otherwise, I can pick up one of the last year detailed comment, line by line comment, so that you can see what I'm looking for. But as I said, at this stage, all you have to do is just make more graphics, because I know that many projects they don't really come up with a graphic. It could be just a picture on Google. Search for a picture, because you are going to present 10 slides. 10 slides you will not present with the text. You present with multiple pictures or figures or flowcharts or cap or illustrations. Create that now, so that you can visually explain your project. Like how I presented the asbestos, I could have made it all text, right? I explained that by showing a picture of somebody standing on a field. Even though that doesn't, it's not scientific, that gives you a message, and that's exactly what I'm looking for in your report. More, um, the more you put figures, the less you have to write. So that's the advantage of it. Um, but don't fill the figure complete page like one small figure and entire page. There's nothing else. But again, I'll give you feedback. So in the final is what counts a lot. Draft stage, I don't keep take a lot of point at all. Most of the, and just to give you a perspective, nobody get less than 90 or 95% in final draft. Because after you go through these comments and everything, you almost all of you get it right. So this is more like a final exam where you get 95%. So think of that, and you have the options to go back and rework on the things that you could not figure it out first stage. And also you have the option to be creative and think of all the wild imagination of how you can solve the problem, and you will still not get any lose any point. As I said on the recording, I remember that one in 2018 or 19, one student, he come up with this plan. He said that no, I am going to solve all these nuclear waste problem by shipping them onto Mars. Okay, so I said yes, that's your project. Go ahead and work on it now. So he did actually work on it. He said we could ship all the nuclear waste to atmosphere and nothing will happen. Then he calculated that the cost of shipping 1 kilogram of waste is way more than what he can do here. So, because just one glass of water in Mars is so expensive, because to carry 1 pound, just calculate that, 1 pound of weight to lift something against the gravity just to take it at upper atmosphere, how much energy it takes. You can calculate that, right? So I mean, just by lifting it, if you just by mgh, just put that, or have take the height, that account, you'll see a high amount of energy. And then obviously when you transfer from one energy to another, you have efficiency 30% or lower. So you have to put a lot more energy to move it to that far. So you realize that even just taking small amount of things will be billion trillions of dollars. And then at the same time, you if you imagine one time there is accident, all the will have rainfall with all the radioactivity. So what I'm trying to say is don't be afraid to have radical ideas. Okay, there's nothing wrong with that. I will not take point for that. I want you to think. So in your projects, write whatever you feel like, as long as it has some scientific basis for it, it's fine. All right, so I think I'm going to stop recording.